father's holding a banquet for the Gerudo leaders. They've come from the desert to make a treaty of peace. Although, I have terrible doubts about the leader's motives. He's a sorcerer. Who knows what sort of spell he'll put us under.
Have been executed perfectly, my lord.
So you put the Servine roots in the king's goblet, then?
Yes.
Good. Now when the king falls asleep and his guests are ushered out to keep from waking the tottering old fool, you'd best keep that glabrous head of yours hidden in the shadows, or it will be staked on a pike outside this castle when I am king.
Yes, Lord Ganondorf.
Hey everybody, I hope you all had a great weekend. I sure did. I actually got Mario Odyssey and definitely loving that, so that was most of my free time, but I did have a little bit of time to plan ahead our next big step in the Tactical Lizard Tamer, which is again my Pokemon slash Fire Emblem like game that we're going to be returning to after a small break to do the 2D lights. Speaking about that, I should probably update my stream title. So our main goal for now is we're going to do the pretty map graphics. So right now in the current game, we have this, which is, well, this map is really huge. I need to probably change it around, or shrink it so this is more manageable, but right now the map doesn't look that good. It's basically just flat hexagons stacked on top of each other, kind of Minecraft style, and that could work, but I want something a little more nicer to look at, where the tiles kind of blend together a little more. And instead of just popping straight out, they'll have kind of a ramp up between the different elevations. So right now we can just pop this off. And there are some good tutorials that do something similar. If you've heard of the website Catlight Coding, he's actually done a huge project about pretty much how to make a hexagonal terrain mesh like we'll be doing, but ours will be a little different because mostly modding complicates it a whole lot, because we need to make it possible for mods to add different terrain tiles, and also our terrain mesh needs to be deformable during the game because one important thing I want to be able to do is for abilities to be able to basically pick up and move these terrain blocks around the map. So in order to do that, we'll have to make the map able to be regenerated on the fly. And yeah, we'll get to that. So we'll be saying goodbye to these alternating hexagons pretty soon. Alright, so we want to get back here. So first what we're going to do is do the data structure. I actually just remembered something. We want to be able to do... we want to update mouse picking around here. I just want to leave myself a reminder. And so I have this separation in the game code between the game logic and then the UX, which is like the... let's get down to it. The user experience, and that's more like graphics and input code that's kind of like specific to Unity. And since all this is going to be exclusively for the graphics, basically all this code is going to be in the UX structure. And the reason I do that is because I don't really want the game logic to ever really have to care about the graphical representation of the game. So that's an easy way to keep them separate. So ideally, any class in the UX can reference classes in the normal game logic namespace, but not vice versa. I don't think game logic should ever have to access the UX classes. Within reason. We'll have to, when we get to the optimization stage, we might have to do a few shortcuts, but hopefully not. Alright, so we have this map. But one thing also is we need to be able to generate the terrain mesh during the loading phase as well, because the first generation will probably be the slowest, and so it'd be nice if we could generate that before moving on to the map. So I don't really want these terrain classes to be inside this map namespace, because this is just for the play and team building scenes. So let's just do a separate, I guess we could just call it terrain. That should be okay. I mean, it's a little similar to map. Maybe I can just call it terrain mesh, because that's basically what it'll be about. Oh, I meant to do a folder, not a script. Okay, so the first thing, I guess we'll just create a terrain mesh class, which will kind of be the overarching class that will basically be the lens for the rest of the game to access all this information. Okay. And this should be public. So this is going to need a reference to the game data at the very least, because we'll need to... Oops, I don't need that. We'll need to be able to access the board so that we can tell at least what terrain is there. Okay. So just to make this easier, let's shrink this map to one layer, and also let's make it 5 by 5 to start out. And to do that, we've got to open up our Lua script editor. And okay, so yeah, we're working with pathfinding, but we're all done with that for now. So we have this map generation. So let's set the dimensions to 5, 5, and then one layer. Okay, so what this does, it does the alternating stone or dirt, which is kind of nice. And this adds other layers, but we don't need that for now, so I'll just comment those out in case we want to get back to it. I should actually change this from field generation to something else, shouldn't I? Because I think we changed everything to board instead of field. So while I'm here. Okay, so what we want to do is just, for 5 columns and 5 rows, we'll just set the prototype. Let's just make everything simple and just set it all to dirt. And okay, so now I'm going to need to update that name in the map generation. Okay, so that should add and remove that variable from Lua. Okay, so let's make sure that this generates correctly now. Okay, and yeah, the monsters now are, oops, why did it pause? Oh, there's an error. Are in a weird spot because their positions weren't updated. But we can see there's 5 by 5 and 1 layer, so that's good. Let's look at the error while I'm here. Okay, so yeah, that's because the monsters are placed at a bad position. When they tried to figure out if a certain ability was usable, it saw that its board position was out of bounds. I guess we can fix that. Let's just set them... that's not it. I want team build and testing default creator. And now I just need to set their positions to... Okay, let's just put one at the top left and then the other at the bottom right. Oh, okay, but now they're inside the map, which probably causing a different error. Oh, right, because 0 is out of bounds in Lua indices, and... Okay, so what I have to do is place the monsters 1 position up, of course, because they stand on top of the terrain. Okay, so that looks better. Okay, there's still an error. Board position 113 out of bounds. Okay, so where does that come from, I wonder? At line 70. I think I closed this already, unfortunately. Simple pathfinding. Okay, line 3. Interesting, so somewhere in here it's throwing an error. Board position 113 is out of bounds. I guess we could just, I don't know, let's see if we can fix this real quick. So move the interface and battle state, get block. Okay, so if this returns null, then it's out of bounds. wonder what the stack trace for this is. Does it tell me a little better? Okay, so yeah, the tick, and then this is all just about errors, isn't it? Trying to read through this. Okay, Pathfinder Manager at 68. And that I think that calls the error message. So let's look at that real quick. Okay, so it just found an error in here, but it's not going to give me the better. The entire stack trace of the actual error. It's just like rethrowing it. Because I'm trying to figure out where this 113 was actually called, because I don't know why it would go up to a different layer unless I was like hard coded that somewhere, which I guess could be. Where is this called? Yeah, in horizontal neighbors, and then checks above and below. But wait, how could it throw an error unless is and board is throwing an error? Let's look at that. Oh, well, the thing is and board is actually a function, and I'm calling it like a variable here. I think that was probably the problem, because this was always returning true because isn't board function existed, but it wasn't actually evaluating it. So let's see if that fixes the error. Okay, yeah, so that's fine now. Because we can just, for curiosity, we can go ahead and look. Okay, so it says that there's no movements. It's a little strange. Well, I'm not going to worry about that right now because we've moved on to something else. Let's turn off warnings. And any errors that we could be due to that we'll fix in due time, but I want to move on. Anyway, actually, no, I'm kind of curious, but okay, well, there's something wrong with the indicators actually, I think, because the normal move function doesn't even work, it looks like. Okay, but we'll figure that out. Anyway, where was I? Need this kind of thing. So we wanted to just set up a good board to get started. Alright, so we'll definitely need a reference to the board. So I'm trying to think what function or what classes should be passed to this. Because I kind of want the terrain mesh. Like, this object won't respond to events, it will just rely on other classes to kind of tell it what to do. But it will be able to generate itself. So I guess the data, probably the game data and the battle can be passed right here. This will, again, basically the game data holds all of the like assets for the game, where the battle is the current state of the map. So it'll need both, definitely. Okay, and then we'll need obviously the Unity mesh. So right now what I want to do is just kind of make... I'm not even really going to look at the battle right now. I just want to make... Oh, okay, wait. I had this in this order, that we'd find the surface first and then make a flat grid. I guess that's fine. So we'll need to set up a mesh here. Actually just a mesh. And this is Unity's object that basically holds all the information to send to a graphics card about a mesh. You can also use it for colliders, and we'll probably be using both. In fact, I'll go ahead and rename this to the graphics mesh, because we might have a separate collider mesh, which would be simpler for mouse picking. Okay, so let's just store all this information and go ahead and create the mesh. Yeah, we'll go ahead and mark it dynamic. Oh, it's not gonna have frequent updates, so might not need to do that. Okay. And then we'll need to expose this so that whatever class takes care of actually displaying this mesh will have access to it. Okay, so let's go and let's do something very simple. We'll just have some object or mono behavior here that will basically grab this terrain mesh data and place it into a Unity object to actually display it. What do I want to call this? It's not really the renderer. I guess I'll just call it the display link. Okay, and this will be mono behavior. Okay, yeah, that's fine. Must be public to be placed onto an object. Okay, and then on start, oh, I need to call it override. So we'll get, I guess I can go ahead and make this terrain mesh an I component, which basically means that I can insert it into my component registry classes, which I use for the rest of the game, where that just hold information and let other classes just grab whatever they need, basically. Okay, so I don't think I'm gonna have to really do anything except here on start. I'll just get the terrain mesh object. So get tactical lizard tamer component. What's it not like? No, I shouldn't have to have a tag, do I? Oh, I just didn't rename this. The tagless version. Still not happy? Oh, that's right. So the terrain mesh, in order to be a component, it needs to have a parameterless constructor. So I guess we'll have to rely on somebody giving us this data. we can just have a void setup. Okay, so this works fine. Okay, so on this component we'll have a mesh filter. Which is the Unity component that you basically attach a mesh to in order to get it to display. And we'll just set it here, and we'll have set up the correct materials and everything already, at least for now. So shared mesh equals terrain dot graphics mesh. What's it not like about this? Type or namespace. Now convert method group get component to mesh filter. Not sure what's going on there. Okay, I think I just need to restart Visual Studio. Sometimes that happens. It was saying that it couldn't resolve that function, though I'm sure that it does exist. Okay, so now it's happy. And now we can go ahead in Unity and set up. Okay, so we have this block prefab creator. I guess I'll just leave it for now, but actually no, because it'll get in the way of the mesh that we're just about to create. And so yeah, we need two objects here. First the mesh filter, which again is what the mesh will be attached to, and then the mesh renderer. And so we'll need to attach some kind of material here. I'm not really sure how this will work in the final game, so let's just make a kind of just test material. Let's put it in the assets folder, we can always move it around. So we'll just do a standard. Let's not do so boring, let's pick green. And yeah, that's all looks good. And if we set this material here, that should be rendered when we create the mesh. Although right now, if we play the game, nothing will actually be displayed except for the monsters, because we don't actually set up the mesh. Oh, also I didn't even place the display link yet. But even still, I think that this will be filled up with something. Not set to, not quite yet. So either, that's weird, either game or components is null. That shouldn't be the case at start. Okay. Spring 11 at start. Okay, so what is null exactly? Stop. Okay, so I set a debug hook there so that hopefully when terrain mesh will be the first time that it calls it, we can get the values of all these. Okay, so the game is null, and it's terrain mesh display link. So why did that happen? I thought the game maybe it should be set before the start. Let's look at this. Oh, it's because I forgot to call base start, didn't I? I always forget in C# you need to do that. So basically, if you override without calling base start, the parents method will never be called. I'm used to languages where they always call the parents first and then come down to you, but C# doesn't work that way. I guess it's nice because you can control what code runs before and after the parents function, but obviously I'm still not used to it. Okay, but now that we called that, we can see that there is a mesh here, although yeah, it doesn't have a name, and also it has 0 vertices because we didn't actually create anything in it. So if we go back to the terrain mesh, maybe we can give it a name so something nice will show up. Okay, let's just call it terrain graphics mesh. I guess we don't have to have the mesh in there. And let's just give it 4 vertices. And I know I worked a lot with these in the previous project, but if you missed that, a mesh is basically made up of vertices, which is points in space, and then triangles, which basically tells the game how to fill in between those vertices. So we'll do something very simple here. So let's just make, I don't know, I'll have another vertex at and then okay, I'm trying to trace this out in my head to the left, and then that's up here. I guess it should start at 0, 0 if I'm going to do it this way. Okay, so then 1, 1, 0. 1, 0, 0. Okay, so this is again, oops. Basically it starts bottom left, then goes up, right, down. So now we need to make triangles for each of those. And as we also experienced a lot in the previous game, the triangles need to what's called have clockwise winding, which basically means that the order that you visit the vertices need to be clockwise in order for Unity to display them. And so clockwise here, starting at the bottom, would be vertex 0, 1, 2, and then another triangle at 0, 2, 3. Pretty sure that's right. Could have always visualized this wrong in my head, but hopefully we should see a little square in the middle of the screen. And we do. And it's green because that's the material we have attached to it. This UI canvas makes it kind of awkward to look in the editor view. I wonder if I can turn that off. There's probably some way to do it. Oh yeah, canvas. Oh, it's still there. Oh, rec transform, is that it? No. Oh well. Make this inactive. Okay, so now we can see our little terrain mesh object. And of course, when we look to the other side, it goes invisible because now the triangles are counterclockwise with reference to the camera. So now they're magically visible again. So that's basically why you have to keep track of the winding direction of the vertices. Okay, so now we have a mesh set up, and again our train graphics mesh shows up in the mesh filter, and so now we have the basics all set up. Okay, but obviously we don't want to do this right here. We want to get the data from the actual board and create something that actually makes sense. So one thing we'll need to do is, right now the board, let's pull this up. So it's kind of, well, it's an array, but I set it up based to make like a cube. So basically all that, for right now, for our 5 layer or 5 column, 5 row map, this array will kind of be set up something like this. Useful this is going to be now that I think about it, but it's nice to try to write things out. And so the block, I think closest, well, let's pull this up and see. It might be nice actually if we display that, oh well, the blocks are actually gone, of course. If I turn this back on, will they display? No. Okay, let's bring back the old blocks just so we can see the map as it is. Okay, so right here, oh yeah, where the gold monster is, this is block 0, 0. And so that is obviously this first position in the array, and then it goes along the column, or along the row here, and then it moves up like that. And then where silver is the last element in the array. And that's kind of how the game, well, and if we had another layer, there would be another 25 vertices up here for layer 2. So what we have to do is we need to find basically the topmost block in the map, and that's how we'll generate the terrain. And you might be thinking, well, what if there's like caves or something? Well, we're just not going to allow that kind of stuff in this game. Because on the scale that I'm planning, which is kind of like Godzilla, so like, I don't know, skyscraper scale, there probably wouldn't be any caves big enough for Godzilla, so there's no reason to even model that. Let's see. So we need to find the surface of the board is what I was trying to get to. So it's basically if we have multiple layers, which I mean we don't right now, but we will, we need to search from the top of the board down through every layer for the first non-transparent block. And that's what will generate. Let's see. Let's just make another object to do that, I think. So let's call this, I guess we can just call it the surface. Sounds good to me. I mean, another option is to actually keep this in the game data itself, but I don't think that's worth it. And actually, I probably won't even store the information in this class. This is whenever something needs to find the surface, we'll just basically search through this data to get it, instead of creating my own array with heights or something like that. We'll see. That might be worthwhile. Oops, I don't want to type in public twice. Okay, so this will need to have a reference to the board. Okay, and for right now I won't cache any values, but that might be useful to do just for optimization. Okay, so what we want here is to get the layer. What do I want to return here? Either the layer or the actual terrain itself. I guess the layer is probably better. Ooh, I did it again. Get layer, and then we'll have the column and row. Okay, so first we need to do is we can get through the layers by just adding and subtracting the layer size, which we have right here. But first we'll need to actually get the starting position. So this will be layer 0, which is oops. Okay, so what I actually need to do is create a new hex position, column, row, and then at the beginning, or the first layer, and then get to board index, and that will give me the board position for this layer, or sorry, the row and column position for the first layer, which is first in the terrain array, and then we can basically loop backwards. So how would I tell the number of layers? I guess it's block data divided by the layer size, isn't it? Oops. Why is it not like that? Oh. This is the map, which is the terrain, and then we divide that by the layer size. Okay, so we start at the first layer, which is num layers -1, and then we'll iterate downwards. Oops, it should be L. Greater than equal to, I keep pressing the wrong keys. And then we iterate downwards. Okay, so for now I'm just going to assume that any terrain that has an index greater than 0 is solid. That probably won't be true in the future because we'll probably have liquid, like water blocks, which we'll probably need to see through. But yeah, we'll handle those differently than this anyway. So let's see. If board map, so layer 0 plus L times layer size is greater than 0, then we return this layer. Otherwise, there's been some mistake. So should we just return the first? No, let's do -1, I guess. This should never happen, but yeah, in fact, I think I'm going to make it so that we just return 0 automatically, because we'll probably have some special case in the map generation so that the bottom layer is always some solid block that can't be moved. Okay, so this is good, and I'm glad I want to have this as a separate class because, like I said, in the future we might want to cache these values, and it'll just make things simpler if we do it all from this class. That way we can change this however we want and it won't affect anything. Or anything outside anyway. Okay, so this terrain mesh, do I want to have, I kind of think this mesh should just have like references to all the relevant data and classes, but then I'll have a separate class that will actually do the generation. So what do I want to call this? I guess we could just be really simple and just call it the generator. We can expand on that name if we need to. Does not need to be public because nothing outside this namespace will ever interact with it. Okay, so this will need to have a reference to the surface and also I guess it'll need to battle. I don't know if it'll need anything else. We'll need the mesh, I guess. So one thing I've been going back and forth on is if I want to have basically an intermediate class in between the raw data and the mesh. Or an intermediate data layer. I mean, I keep going back and forth because on one hand it might make things a little bit easier, but I think it might also slow things down. But the reason I'm trying to decide now is because we need to decide if the generator will work with the mesh directly or if it will just output some data that there'll be some other mesh builder. That might be better actually because if we do have a separate collider mesh, we won't want this generator to have to handle both. So I guess then the question is, what data will this generator export? Maybe a list of triangles or something? No, because that's again really low level. Maybe this will just generate like a 2D array of the surface, and then from there we'll have another class that will turn that into the graphics mesh by basically turning each of those hexagons into a triangle. And then it'll have a simple data for the heights of each hexagon. Okay, so think about that. This class should basically output almost all the data that it can so that the mesh can just take it and not really have to look up anything else and then build upon it. Or build the mesh just from the data that this generator exports. So let's I think we need to be a little more descriptive in the name actually. But what do I want to call this? Guess I could call it the blueprint builder or something, I don't know. So we'll have like a separate mesh builder. Let's go with this. Okay, so I guess we'll start like, well no, we should go ahead and pass the battle at the very least. And then it can go ahead and set up the surface. Okay, why did my script color decide to stop working? I don't know, sometimes it just does. Okay, and so this will generate we'll have some function to start building whatever data will output, which I guess is what we need to decide now. Be some kind of list, and I basically need to have some data about each hexagon in a way that will make it easy for the mesh generators to do their job, because they're going to get pretty complicated. Okay, well let's see. For now the mesh generator is basically, maybe we should work backwards and see what we need exactly. Again, shouldn't need the battle, but it'll need to be passed some data, which we're going to need to figure out. I guess maybe we can pass it the mesh already. Oops. Oops, what am I doing? No, I'm not assigning right now. Okay, I don't know. I'm getting way far ahead of myself. Okay, so here again we'll have a generate function, and this is where we'll pass. Oops, I forgot the void here. The data to the map, or the mesh generator. And so for now, oops, sorry. Left this running the whole time. Okay, so we pretty much took care of these already. Pretty simple. So yeah, we want to make a flat grid, which is what we set up here with the map. And I guess for that all we need to know is basically, for now we just really need to know which hexagons exist. So let's do let's have this class which will hold all the data that the blueprint builder sets up.
Nah, I need something dirtier than that.
And then let's have
That's what I'm talking about.
cell.
It's dangerous to get at me alone. He gonna have to take this.
And I don't know if we even have any information in it yet. Just it merely existing will be enough for us to build the data around it. Although, why don't I go ahead and set like the world position? I don't know. That might be nice, actually. We could probably just have like the hexagon radius in the mesh blueprint that we'd pass to the generator, or the mesh generator. Anyway, so we'll need... I'll just make all these public because there's not going to be any helper classes in here. This will basically just be a data container. Radius, and I think that'll be good for now. How do we do? That's not what I wanted. Oh, it's in the map, of course. The block prefab creator. Okay, so this is actually held in the hex position class I created a while ago. Actually, oh, I see. So, yeah, given a radius and a height, this will give you the world position in the center, which is fine, I guess. But yeah, we don't. We just have the radius as 1 here. I guess that's okay. Okay, so let's just do something really naive and simple here. We'll just make a vertice on the edge of every hexagon, and then create triangle to each one. That'll be the simplest way, and I mean, technically, yeah, we'll end up making 6 triangles. Technically, you could do a hexagon, I think, and much less, like 3 triangles, but it'll be easier in the long run if we do 6 triangles in the mesh, because we'll be editing the borders around them. Later on we can, towards the end of this, we'll be able to minimize them, I think. Okay, so let's see here. This should just be generate. So first we'll need a list of vector 3, and this will be the vertices. I'm not going to worry about caching any of these values yet. And then we'll also need a list of integers for the triangles. Although now I think of it, just for ease of use, I think I will move these out. That way multiple functions can use these lists without me having to pass them around. Okay, so I guess we'll instantiate them here now, actually. Okay, so let's have another function to triangulate hex top. Okay, let's think it too far ahead. Let's just call it this for now. And it will have the index. Let's call it cell. And then just for ease of use, I'll make a add triangle function. Oh, it shouldn't be vectors, it should be integers. And again, they need to be clockwise, but we'll deal with that. Okay, so this is just triangles add A, triangles add B, triangles add C. Okay, so again, we'll need the center, and then we'll need to add a vertice at each point along the edge. And the center we can get using the hex. What do I call it? No, a hex position. Although we should try to copy, or like, it's a little awkward that this hex position has this world space, because this again is UX stuff in a game data class. But I have a couple classes that actually use it. Okay, so I'll leave this in for now, but we need to deprecate it. Which basically means we just need to stop using it and at some point remove it. So I'll just copy this out, because we'll use this same math, but I need to put it somewhere centralized in the UX classes instead of the game data. Maybe I should just... let's see, so this will be something like, I don't know, hex math. That's not what I wanted to do. So private, I guess I'll just copy it over exactly, and then I'll end up having this hex position just call this hex math class, which obviously is not what we want to do, because as I said before, the nothing in the game logic should ever access UX classes, but for now it'll be okay. Oops, I put static in the wrong position. Okay, so we also need to have... Okay, we can still use this hex position here to get the column, row, and layer. Square root of 3. Static. We can just use the hex position, square root of 3. Okay, this math is basically how you convert from a row, column, and layer into a world position. Which, let me see if I can grab that up real quick. I have this really good website called Red Blob Games. Has a nice webpage about pretty much everything you'd want to know about hexagon-based maps. And that's how I got where I got this function, but I'm trying to figure out where it is now. Maybe it's this is from different types. So I could just show the math. Maybe it was, oh yeah, hex to pixel, I think. Yeah, because we wanted to convert the center of the hexagon to the world position, which is basically pixel position in space, and then I added in the z. But yeah, so it's basically the size of the pixel times square root of 3, and then you add the column and row. He uses Q for column. So that's what this math is here. This should be float, shouldn't it? And then I basically added in the Z because it's, I don't think, yeah, this website doesn't deal with heights at all. So I wonder if we can use this same thing, well, to find the borders. It doesn't, yeah, it doesn't do that. I'm not sure. So, I mean, there's got to be an easy way to figure out the position of each edge. I guess, well, obviously, now that I think about it, we can just use sine and cosine, but we'll probably want a faster way to do that. Yeah, because obviously, okay, so this is how they get the corners. It's pretty easy. I forget if we decide to go with flat topped or pointy topped. I think flat. I guess I can look in the game. Although at this point, yeah, the game's not compilable. Okay, so anyway, let's get back to this. Oh, and then I need to convert this to use hex math just temporarily. Okay, and then we can get rid of that. Could mark this as obsolete, but then I'll get lots of warnings. I guess that serves me right. Okay, so yeah, we're done with this. Okay, so for now, we don't really care about the height, so we can just call hex position. Oh wait, no, we need to call hex position from board index, and we pass the board and this index, which should match up. But we don't have a reference to the board. I don't really want the mesh generator to have the board data, do I? Although that does make this a little bit more annoying to use. Okay, well I guess we can easily figure out the row and column. So yeah, we'll need to know the mesh blueprint. And so the blueprint should tell us like the row size, although it doesn't yet. And then again, this is just, we want to be able to transform the index, which is all in one array, and change it to columns and row. And so this way, this modulo of course will loop back the return value whenever we reach the maximum row size, and then integer division, we'll just keep it every time that, well, basically every multiple of 5, it will give us a new index there. So this is how you can convert from an array index to rows and columns. And then I guess we'll just return 1 there. I don't know how we'll specify that. Probably the mods will be able to give the array or the hexagon radius and height. Okay, so we have the center, so we need to add this as a vertice. That's just kind of the count where we start. So vertices, add center, and now we need to add each border point. And I guess we should put that in here as well. So let's see, public static vector 3 get world yeah, corner is what I meant to say, not border. Let's actually call this get corner world position. That makes more sense. Maybe a better way to do it would be to just get the offset for each corner, because we'll already have the center. Okay, so we'll pass, I think we'll just need the radius here. Oh, and of course the actual corner. And let's see, I guess I'll need to see. I think 0 would be out to the right, and then it would go around clockwise. Oh no, it'd go counterclockwise. So that might not be how we want to handle it for us. Okay, I want to get to a compilable place so I can start up the game and see if we have the hexagons flat-topped or pointy-topped, because that will affect the way that we get those corner offsets. Okay, so yeah, this is straight on, and then if I rotate, okay, we actually have it pointy-topped. Not that that's that difficult to change, but yeah, this should be fine. So that means we want probably first to be here, and then we should go clockwise around. So yeah, north will be corner 0. So corner 0 is north, and proceeds clockwise. Is that how this is set up? So we actually have pointy topped. Yeah, of course, in math, here is angle 0. So if we want this to be angle 0, we'll need to add 270 degrees, obviously. Or conversely, subtract 90. Okay, so let's get this. Okay, so yeah, 60 times I minus 90 is how we'll set this up. And actually we want this to be in radians. So I'm just going to use a little helper here. Why are you not giving me the function to... Oh, right. So degrees to radians times 60 times I. We gotta do it here. So this will convert degrees to radians. That's what they do here, but... And then I don't want to return a point, I'll just return a vector 2. I guess I'll do a vector 3, just to make things easy. It goes ahead and adds the center. But in case we don't want that, I'll just have the give an offset. And now I just need to use Unity's cosine and sine functions. Of course, we can always, cosine and sine, they're kind of slow, but not super slow. Obviously, we're going to have to be doing this pretty often, so it might be nice to have like a lookup table for these values for every corner. But I just want to get something up and running right now. We can worry about optimizing later. Okay, so now we're going to loop through each corner, and obviously there's 6 corners in a hexagon. So we want to add vertices, add hex math dot get corner world offset. Okay, we're just going to return 1 for now, or use 1 as the radius. Oh wait, and then we want to add in the center. Okay, now we'll add 6 triangles. I guess we can do it. Yeah, we'll need to loop again because we'll have to wait until after the vertices have been added. I guess it doesn't really matter that much, but... Add triangle. So let's change this. The center vert index is vertex count, which is what the position we're going to add that. So we always want to have center vert index as the starting position, so it'll always be point A on the triangle, and it has to go around clockwise, so should always start that's the first corner and then the next corner over. And we need to modulo by 6 so that we wrap around when we get to the very last triangle. Okay, so basically we add each vertice. Well, let's assume this is the very first cell we do. So the center vertice is at position 0, and then we add one vertice for each corner starting at the top and going around clockwise, and they're all at position 1, 2, 3, 4, 5, and 6. And so we want to add a triangle going from vertices 0, 1, 2, 0, 2, 3, 0, 3, 4, etc. So that's what we're doing here. Of course, I starts at 0, so to get 1 we have to add 1. And then here we add 2 to I, but then we need to do a modulo to circle back around, but I actually did this. It's a little more involved because we wanted to do the modulo first and then add 1 so that it goes from 1 to 6 instead of 0 to 5. Okay, so there we go. And now let's just pass the mesh blueprint. Hopefully we'll be able to I'm already out of time, but I like to run this. So for int I equals 0, I less than blueprint cells length. Oh, count actually. Oh well, yeah, because we have to create the cells and everything. So yeah, we won't be able to run that tonight, unfortunately. But at least we got this done. So again, this is something very simple, just to create a flat mesh for each surface hexagon. And right now it's really unoptimized because like these corner vertices can actually be shared between adjacent meshes or adjacent hexagons, but we don't do that right now. And we will need to, because one of the cool things about this algorithm or using these meshes is that we'll be able to, for different terrain types, kind of blend colors together. 'Cause that's the main thing we're trying to fix right now. We don't really want Minecraft style. Not that anything's wrong with that, it's just not what I envisioned for this game. Something more like Civilization, where each hexagon, the colors blend nicely, although now everything is green, but before it just had a quick break to gray for the different types. And yeah, so we got a lot of preliminary stuff done today, and I think we're well on our way. We should be able to maybe add an elevation tomorrow, but definitely have a flat mesh. But we'll be working on this project probably for quite a few weeks because it's pretty involved and just a lot to do. It'll be fun because we'll touch on more of this math kind of thing, and then to offset that we'll have some shader work and some modeling down the road, and maybe even some physics stuff with mouse picking. But anyway, I hope you all enjoyed the streams. It was a bit math and planning heavy, but since we're starting a new project, I think it's can't be avoided. But I'll be back tomorrow around 8:30 Eastern, and we'll continue on with this. If you missed any of this stream or any previous one you'd like to check up or catch up, I do upload everything to YouTube, so you can get there from my channel description or typing !YouTube in chat. I also have a Discord channel if you'd like to come chat with me and other viewers. You can get there by typing !Discord in chat or looking in my video description. And yeah, again, thanks everybody for coming by and watching. I do appreciate it. I hope you have a great night. Alright, bye bye.